What if we wanted to evaluate the standard deviation and the variance within the confidence intervals? We need to have the chi-square distribution. Till now so far we have understood what exactly the Z distribution and T distribution. Now we are going to understand the chi-square distribution. Now let us understand what exactly is chi-square distribution. Guys, here we have to clearly understand one thing. Till now so far, whatever the population parameter that we have concentrated is mean. Now this chi-square distribution will be used to concentrate on the sigma square and sigma. Sigma represents standard deviation, sigma square represents the variance. So the point estimate for sigma square is equal to s square, and the point estimate for the sigma is s. S square is most unbiased estimate for sigma square. Okay, the most unbiased. You can use the chi-square distribution to construct the confidence interval. So here the chi-square is represented in terms of a lambda or chi. Actually, this is called as a chi-square. Actually, chi. Okay, you should not call it as lambda. Sometimes they will represent it as a lambda. Okay, so if the random variable x has a normal distribution, then the distribution of chi-square is equal to n minus 1. See what is happening here. S here s square n minus 1 s square. Actually this is how you're going to get like sigma square divided by n minus 1, so that n minus 1 will come to the top. N minus 1 into s square means point estimate divided by sigma square. Got it? This will forms a chi-square distribution for the samples of any size n greater than equal to 1 or n greater than 1. Understand? So this forms a chi-square distribution. We have a couple of properties that we need to understand for the chi-square distribution. All the chi-square values means this part. Chi-square values are greater than or equal to 0. Chi-square distribution is a family of curves, something like a T distribution, but this is different. Each determined by the degrees of freedom. Of course, that we know the degrees of freedom, which is df is equal to sample size minus 1 in the T distribution. To form a confidence intervals for the sigma square, use the sigma square distribution with the degrees of freedom equal to 1 less than sample size. Okay. So though the area under the each curve of the chi-square distribution equals 1. Of course, we know that. Find the critical value ZC that corresponds to the given level of the confidence. Just chi-square distributions are positively skewed. So let us see and understand. We know that this is a, when they said like the chi-square distribution is a positively skewed, the tile would be traveling towards the right hand side. And when I say like, if the middle area is a C and rest of the half of left and the right tail represents 1 minus C divided by 2. So the area between the left and the right critical values is C. Got it? Okay. So here, find the critical values. There is a sum. Find the critical values chi-square right, chi-square left for an 80% confidence interval when the sample size is 18. We know that degrees of freedom is equal to n minus 1. Sample size is 18 here. 18 minus 1 will become the 17 degrees of freedom. And according to area to the right of the chi-square, definitely we have to substitute the given confidence interval, which is 0.8. 1 minus 0.8 divided by 2 will become the 0.1, whereas the left of the chi-square distribution value will become the plus, equal to 1 plus 0.8. So if you, this is what we have checked it here yesterday, just now. Area to the right of the chi-square, 1 plus c by 2. Area to the right of the chi-square r. Chi-square r is different from chi-square L. Okay, why? Because chi-square L represents the left tail critical value. Okay, so this one, right tail critical value is something like this one. This is 1 minus c by 2. 1 minus 1 minus c by 2 will become 1 plus c by 2, okay, which is the middle area. Okay, so this is the one where you want to understand. 0.9. Use the chi-square distribution table to find the critical values. So here, this is the chi-square distribution. Okay, degrees of freedom we need to understand. 17 is the degrees of freedom. And what is the value that you need to identify? For the left, it is, what is for the left? 1 plus c by 2. For the right, 1 minus c by 2. Right or wrong? Which is 0.9 and 0.1. So for 0.9, you can see 10.085. For 0.1, it is 24.769. So we can clearly say the confidence intervals are in between 24 percentage and the for the left chi-square is 10 percentage. So here, this is always have a range of a confidence interval between chi-square R and chi-square L. That is none other than n minus 1 s square divided by chi-square right, n minus 1 s square divided by chi-square L. The probability that the confidence intervals contains sigma square or sigma is, means whether it may be a standard deviation or a variance. Okay, it is a C. This is how that we need to identify the chi-square distribution. This is the overview of all the formulas that we have followed in so far about even identifying the variance, which is sigma x minus x bar whole square divided by n minus 1, which is a sample variance and sample standard deviation. Okay. Now we have a one problem. You randomly select and weigh 41 samples of 16-ounce bags of potato chips. The sample standard deviation is 0.05. Assuming the weights are normally distributed, okay, construct a 90% confidence interval. Okay, so we can clearly understand 41 is the samples. And here 41 minus 1 will represent 40 degrees of freedom. Area to the right of this one, 1 minus c by 2. Area to the left, 1 plus c by 2. Okay, so 1 minus c by 2 defines 1 minus 0.9 divided by 2, which becomes 0.05. Okay, area to the left of chi-square L, which defines 1 plus c by 2, which is going to be 1 plus 0.9 divided by 2. Okay, this will become 0.05 and this will become 0.95. The critical values are chi-square R and 55, chi-square L 26. Okay, so chi-square R 55 and chi-square L 26. So here we need to understand the left point and the right end point. So we have the range. How do we identify the range of sigma square like standard deviation? N minus 1 root of, okay, n minus 1. Why? Because if we don't have the root, then it will become the variance. Root of, okay, n minus 1 into s square divided by lambda square r and the root of n minus 1 x square divided by lambda square L. If you calculate, you will get the range of the standard deviation would be 0.04 and 0.06. So we are 100% confident. We can say that the population standard deviation is between 0.04 and 0.06 ounces. Why? Because they have given the sample standard deviation is 0.05. Okay, but we need to estimate the population standard deviation. Okay. So guys, this is what all about the chi-square distribution. So what else that we are left with so far? We are just left with hypothesis testing and ANOVA. Okay, ANOVA means analysis of variance. Okay, so we need to understand the hypothesis testing and we need to go ahead with the ANOVA. ANOVA represents analysis of variance, during which we will be understanding the F distribution or F statistic. Okay, where it will comes under there. So we have got covered Z distribution, T distribution, chi-square distribution, and the F distribution, which will comes under the ANOVA. Before that, we need to cover something very much important is called the hypothesis testing. Okay. So till now so far, okay, I will count on whatever that we have discussed so far. Okay. Can you all please count on with me or type something for me? In the very first session that we have discussed about the measures of central tendency. What else that we have discussed? We have discussed about the measures of variation or dispersion or something else like that. Okay, and next one we have understand the measures of shape. After that, once after the measures, we went and understood what is the best measures of centrality. Okay, and also we understood the normal distribution, and then we understood the standard normal distribution, and then we understood the probability, and then we have gone through the binomial distribution and the Poisson distribution and the hypergeometric distribution, and then we jump on to the some of the sampling distributions. Okay, how do we take the samples and all? Okay, and sampling distribution followed by the central limit theorem. What the central limit theorem says? If your size of a sample is greater than 30, then it follows some sort of distribution. Right or wrong, guys? So that is the sample distribution that I'm talking about. And sampling distribution will follow something like that. And also central limit theorem will say it's like n greater than 30, we have to follow something which is a jet distribution. Okay, and then we also have seen the when do we use the T distribution, and also we understood the implementation strategy of the jet distribution and the T distribution based upon the given situation. Okay, whether the data is normal distributed or not, we need to verify it by ourselves, and then we need to take the decision which distribution we need to use in order to calculate something. Okay, and then now what else that we are going to discuss? We have discussed the chi-square distribution, along with the confidence intervals for the large samples and the small samples and the proportions. Okay, population mean, for the population mean, estimation of a population mean using the confidence intervals, and then the estimation of the variance and the standard deviation using the chi-square distribution for the confidence intervals. Are you all in sync with me, or do you have any questions? Suresh, any questions so far? So that tomorrow we are going to discuss about hypothesis testing. Once we complete the hypothesis testing, we will jump on to the ANOVA. Okay, and then we will switch to the R programming language immediately. Okay, then we will meet again tomorrow and we will discuss about the hypothesis testing. Okay, see you again. Bye.